Welcome to our journey into optimizing JavaScript performance. Today, we're going to break down the key areas that can significantly boost your app speed. First up, we'll introduce what performance optimization really means and why it's crucial. Next, we'll dive into understanding where those pesky bottlenecks might be hiding. Then, we'll explore minimizing DOM manipulations for smoother user experiences. Efficient event handling is another biggie. We'll share tips to keep your app snappy. Lazy loading images and data can drastically reduce load times. Let's see how it works. We'll also cover code splitting with Webpack to make sure our apps only fetch what they need. And finally, optimizing async operations will ensure those background tasks don't slow down the show. By the end of this session, you'll have a solid plan to tackle performance issues head-on. Welcome to our journey into the world of performance optimization. Imagine navigating through an app that feels as smooth as butter with no lag or delay. Performance optimization is what makes this possible. It's all about making your application run faster and more efficiently, giving users a seamless experience. For instance, think of how you feel when loading a website that's super fast compared to one that takes forever. That's the difference in user experience. We focus on reducing load times by minimizing resource usage, like cutting down on unnecessary images or scripts. And it goes beyond just speed. We also enhance the overall application performance so everything works smoothly together. So, whether you're coding with JavaScript or any other language, remember, a well-optimized app means happier users and better business outcomes. Welcome to our tutorial on understanding performance bottlenecks in JavaScript. First up, let's talk about identifying slow parts of your code. It's like finding the weakest link in a chain. Find where it takes the longest time and focus there first. One effective way is by using tools like Chrome DevTools. With this, you can profile your application to see exactly where the delays are happening. Next, let's dive into I/O and CPU bottlenecks. Think of I/O as data flowing in and out, like reading from a database or writing to a file. These operations can slow down your app if not optimized. On the other hand, CPU bottlenecks happen when your code is doing too much heavy lifting at once. By understanding these areas, you can significantly improve your application's performance. Welcome to our session on using DevTools for profiling your code. First up, let's open Chrome DevTools. You can do this by right-clicking anywhere on the web page and selecting Inspect. Or you can use the shortcut Ctrl+Shift+I, Windows, or Command+Option+I Mac. Once DevTools is open, navigate to the Performance tab. This is where all the magic happens. Before you run your application, make sure to click the Record button. Now start running your JavaScript code. As it runs, DevTools will capture everything that goes on under the hood. Once it's done, hit stop and dive into the results. Here, you'll see a detailed breakdown of what took the longest time, which functions were called, and much more. This information is invaluable for pinpointing bottlenecks in your code and optimizing performance. Alright, let's dive into an important concept for optimizing your web apps. Minimizing DOM manipulations. Directly changing elements on the document object model, DOM, can be slow because every change triggers a browser repaint or layout recalculations. This is where virtual DOM libraries like React come in handy. React uses its own internal representation of the DOM, which it updates efficiently. When your app state changes, React only re-renders the necessary parts, and then applies those changes to the real DOM at once. This approach significantly reduces the number of direct manipulations and speeds up performance. So next time you're working on a complex UI, consider using a virtual DOM library like React to keep things running smoothly. Welcome to our example on the virtual DOM in React. Let's dive into this piece of code. We're importing and the hook from React. In our main component, we have a state variable called initialize_to_0. The button here is connected to an event handler that increments the count by 1 each time it's clicked. Now, what's really cool about React is its virtual DOM. This code doesn't directly update the actual browser DOM. Instead, it creates a virtual version in memory. When state changes, React compares this virtual DOM with the real one, only updating necessary parts of the page. That's how React manages to optimize performance by minimizing costly re-renders and improving user experience. Let's see this in action as we update our count. Welcome back, everyone. Today we're diving into efficient event handling in JavaScript. First up, let's talk about avoiding unnecessary event delegation where possible. Delegation is a powerful technique for attaching listeners to dynamically added elements, but it can add some overhead. For example, if you have a static set of buttons that don't change, directly binding events to those specific elements will be faster and leaner. On the flip side, when dealing with lots of similar elements or dynamic content, event bubbling can really save the day. By attaching an event listener to a parent element and handling it there, you can catch all child events without cluttering your code. For instance, if you have a bunch of clickable images in a gallery, listening on the container div works just as well as individual listeners on each image. This not only cuts down on memory usage but also simplifies your event management. Happy coding! Now let's dive into an example of event delegation, which is super useful for optimizing your JavaScript and improving performance. Here we have our code snippet. We're using to listen for a click event on the document level. When someone clicks anywhere, it checks if that click was within an element with the class myElement. If so, it logs a message to the console. This is much more efficient than adding individual event listeners to each specific element because you're only attaching one listener to the parent container instead of many. It's like setting up a single security guard at the entrance of a building rather than assigning guards to every room. This technique can significantly reduce the number of event listeners, making your code cleaner and more performant. Welcome back to our series on JavaScript performance optimization. Today, let's dive into lazy loading. Lazy loading is like having an assistant who only brings out the plates you need as guests arrive at your party, instead of bringing everything all at once. For web pages, this means loading images and data only when they're needed. This can significantly reduce initial load times, making your site faster and more responsive. Imagine a home page that only loads the main content first, and then gradually fills in with images and additional data as you scroll down. Not only does this improve user experience by reducing wait time, but it also helps save bandwidth for both the server and the user's device. So, let's make our website snappier and more efficient with lazy loading techniques. Hey there, folks. Welcome back. Today we're diving into lazy loading with the Intersection Observer API. Lazy loading is all about optimizing your website's performance by only loading what you need when you need it. Let's break down this code. First, we initialize an intersection observer, which watches for changes in the viewport and calls a callback function whenever an element enters or leaves the view. Inside that callback, if the element intersects with the viewport, we swap out its source image from a placeholder to the actual URL stored as data src. We then remove it from observation to avoid unnecessary checks. Next, we loop through all images on our page, add a load event listener to make them visible once they load, set their data src attribute and src attribute to a placeholder GIF, and finally start observing each one with the intersection observer. This approach ensures that only the images in view are loaded, making for a smoother user experience. That's it. Thanks for watching, and stay curious. Welcome to our tutorial on code splitting with Webpack. Today, we're diving into dynamic imports, which are super powerful for lazy loading modules in your JavaScript applications. Essentially, this means that only the code you need is loaded at any given time, improving load times and making your app more responsive. For example, if you have a large application with many features, you can use dynamic imports to ensure that users don't wait for all the code to load before they see what they came for. Let's say you're working on an e-commerce site. Instead of loading all product details up front, you could dynamically import them as the user scrolls down, making your app much faster and more efficient. Ready to take your JavaScript performance to the next level with Webpack? Dive into dynamic imports. Welcome back, everyone. Today we're diving into dynamic imports in React to optimize our application's performance. This example demonstrates how you can load components on demand rather than including everything upfront. Let's break it down. We have a component called myComponent that uses React state and the useEffect hook from React. Inside useEffect, we import another component, myOtherComponent, dynamically. Once imported, we set the state to true, triggering our return statement to render this component only when load component is true. This way, you can delay loading non-critical components until they are actually needed. It's a simple yet powerful technique to make your app faster and more efficient. Give it a try in your projects today. Welcome to our session on optimizing async operations in JavaScript. When dealing with asynchronous code, you might have encountered nested callbacks, often referred to as callback hell. This can make your code messy and hard to maintain. That's where comes in making your life easier. It turns asynchronous functions into more readable synchronous-looking code. For example, instead of writing something like this with promises, you can use to write it like this. This not only looks cleaner but is also easier to read and debug. Happy coding! Alright, let's dive into our example of using to fetch data from an API. Here's the code. We have a function that takes a URL as its argument. This function is declared with, which means it can use the keyword inside. Inside the function, we use to make a network request and get a response object. We then chain another to convert this response into JSON format. If anything goes wrong during these operations, our block will catch the error and log it to the console. Finally, outside of this function, we call with an example URL and log the returned data using. This approach is cleaner than traditional promise chaining because it looks more like synchronous code. Alright, let's dive into the key takeaways for optimizing your JavaScript performance. First off, identifying and addressing performance bottlenecks early on can save you a lot of headaches down the road. Next, using virtual DOM libraries like React or Vue can drastically reduce unnecessary DOM manipulations, making your app faster. Efficient event handling is crucial too. Make sure to use techniques that minimize the number of event listeners where possible. Lazy loading images and other resources based on when they're needed can significantly cut initial load times. And then, don't forget about code splitting. This allows you to load only the necessary parts of your application dynamically as users navigate through it. Lastly, using async/await for handling asynchronous operations makes your code cleaner and easier to manage, all while ensuring that tasks execute in a proper sequence.